Hello everyone. Let's solve today's LeetCode POTD. So the problem is count square sum triples. The problem states that we define a square triple as a triple A B C, where A B C are integers and A square plus B square is equals to C square. Means they are simply the sides of a hypotenuse triangle, and now we are given an integer n, and we need to return the number of square triples such that all of these values lie in the range 1 to n, and n can go up to 250. So for example, if we have n equals to 5 here, then the possible pairs of means this can be, for example, if we have 3 4 5. So here, as you can see, like all ABCs are lying between 1 to n, and A square plus B square equals to C square, which is 3 square plus 4 square equals to 25, and 5 square equals to 25. Hence this is a valid pair. As you can see, like this B and A can be swapped as well, so this will create a new triplet. So in the answer as well, like in the given example as well, they have accounted these two triplets as differently. They have not counted this as same, so we'll also be like accounting them as different. Hence we'll be needing to account through all the possibilities of A and B, and means if a comma B is a valid part of the triplet, then B comma A is also a valid part, so it will be another triplet. So 4 comma 3 comma 5 will be a new triplet, because again 4 square plus 3 square equals to 25, and 5 square equals to 25, and hence the output here is 2. Similarly, for n equals to 10, we have the output as, means the square triples are 3 4 5 and 4 3 5, the same ones that we encountered before, as well as we have 6 8 10 and 8 6 10. That is 6 square plus 8 square equals to 100, and 10 square is equals to 100. So hence the output here was 4. Means again the 3 4 5 and 4 3 5 with a square plus b square equals to 25, and 6 8 10 and 8 6 10 with a square plus b square equals to 100. So this is like the means how we'll be seeing it. So the first observation that we need to make here is, like a comma b is part of some triplet, then if a is not equals to b, so b comma a comma c will be a separate triplet itself. Okay, so we need to account both of these possibilities. So what will be the the most naive manner of going through it? So as we can see, like n can go up to 250, and we need to satisfy this condition of ABC should lie in the range of 1 to n. So let's try to satisfy this range in a brute force manner. So what we'll do is, we'll move A from 1 to n, then inside we'll move B from 1 to n, then inside we'll move C from 1 to n, and in the end we'll simply check, like if A into A plus B into B is the same as C into C, then we'll simply increase our count by 1. Okay, and in the end simply return this count. So we can use this approach, and obviously this will be going to work as the complexity is n cube, and the means the n can go up to 2.5 into 10 square. So that means it can go up to 6.25 into 2.5 into 10 to the power 6, which will go till 6.12, so till 1e8. So this will work in 1 second. Okay, so hence this is the most, means for the given constraints, the most naive approach will also work. And let's see the proper code. So we initialize the count variable as initially as 0. Now we'll be iterating through all the possibilities, and in the end we'll see like whether this condition is satisfied or not. And if the condition is satisfied, then we'll simply increase this count, and in the end we'll simply return this count. So let's try to submit this and see how well it does. So, and whether it means gives TLE or not, because n equals to 250, and as you can see, like it runs, it gets affected, but it only beats 12% of the solution and runs in 231 ms. Hence we definitely need some optimization, and obviously we'll means we need to first step can be to optimize this extra loop that we are having. So now we know that the condition, the formula that we need to satisfy is a square plus b square equals to c square. So if it iterate through all possibilities of a and b and then try to see the value of c based on these calculated a and b's, then maybe we can avoid this extra loop that we are having, because for a particular set of a and b there will be a unique c that will be satisfying this condition, right? So iterating through all possibilities of c from 1 to n is not feasible, obviously. Hence we'll calculate this value of c that is required, and in the end we can check whether this c is lying in the range, means is lying in the range of 1 to n or not. Okay, so what will be the formula? So c is simply what? It will be square root of a square plus b square. So we'll simply use, like, either we can use the inbuilt square root in C++, or what we can do, we can use binary search to find square root. So since the inbuilt square root function is already provided and it is a easy problem, so binary search might be an overkill. So hence we will be simply using the inbuilt square root function to calculate this square root value. Now there might be a case like this. Suppose it is 4, a equals to 4 and b equals to 4. So a square plus b square equals to 32. So square root of 32, since it will always give us an integer, it will give the value as 5. Now we need to know whether this c is means equals to a square plus b square, means a square plus b square is equals to c square or not. Because as you can see, like here we got c as 5. So 5 square equals to 25. But as we know, like a square plus b square was 32. Hence in this case it is not equal, right? So we need to, in the end we need to check whether that c that we have gotten is, if the c that we have gotten, so the c square value will be, c square is simply a square plus b square, and hence c will be getting as square root of c square, c square. Now we need to see whether this means this is a perfect square root or not. Means this should be a perfect square, then only c will be a valid integer. Otherwise it will be some like other number 5 point something which was graded down to the nearest integer. So we need to check whether c into c was the same as c square, as well as we need to satisfy the condition of a, b and c should lie in between 1 to n. So hence we also need to check whether this c is less than equals to n. Okay, so if these conditions are satisfied, then we'll simply increase our count. So we knew that for each pair of a comma b, this c will be means a unique value. So hence instead of trying to all possibilities from 1 to n, we simply find out this c and in the end see whether this c lies in the range or not. And if it does, then we'll simply increase our count and in the end return our count. So we'll going through all possibilities of a from 1 to n and b from 1 to n, and then in the end find this c by these two steps and then simply increase the count. So this will be like the order of n square into the complexity of square root. Now the inbuilt complexity of square root in C++ in most of the architectures is big of 1, or if we try to use binary search, then it will be big of log n, and log n here is 250, means approximately 2 to the power 8. So it will be like 8 into n square. Okay, so this is like the complexity of the solution, this solution. So let's try to see the code and see the implementation. So we initialize the same counter, we iterate through all possibilities of a and b. Now we'll calculate this c square. So this square will be a square plus b square. Now we find out the square root of, we find out the value of c using the square root inbuilt function. So it will be square root of c square. Now we need to see whether this was a perfect square or not. To see, we'll see like whether c into c is the same as c square, and this c should be lying in the range of 1 to n. In this case, we'll be simply increasing the count by 1 and then return the count. So it will be either like n square, based on the architecture this can take constant time, or if you try to implement minus that, it will be big of log of 250, which is nothing but 8 only. Okay, so this will be the time complexity of this approach, and the space is constant here. So let's try to submit this code as well here and see how it does. Initially it means beats, it runs in 231 ms and beats only 12% of the solution. As you can see, like now it runs in 7 ms, which is fairly enough for the given complexity that we got. And this will be like the most optimal approach for this problem. So I hope like you are able to follow both the approaches and how we try to get rid of the inner loop that was redundant here, and then we try to means optimize the approach. So if you did, like do like the video, and if you have any doubts, feel free to comment down and I will be happy to help. Thank you for watching.